Question 10 says, molecules of an ideal gas are known to have 3 translational degrees of freedom and 2 rotational degrees of freedom. The gas is maintained at a temperature of T. The total internal energy U of a mole of this gas and the value of gamma, which is equal to Cp by Cv, are given respectively by, and the options are given. Clearly the question is from the topic kinetic theory of gases, and it is about ideal gases. The degree of freedom is given to us, and we have to find the internal energy of 1 mole of this gas. Now, the total number of degrees of freedom in fact is 3 plus 2, that means 5, and for 1 mole of gas in this particular case, the energy is number of degrees of freedom divided by 2 multiplied by R into T, or F RT by 2, where F is 5. So, that means the value of U will be 5 RT by 2. Well, there are in fact 2 options with U equal to 5 RT by 2. Let us now look at the value of gamma. The gamma in this particular case can be given as Cp by Cv, and we know that Cp itself is Cv plus R and divided by Cv. What is the value of Cv? Well, Cv in this particular case is 5 R by 2. So, if you put here Cv as 5 R by 2, because the degrees of freedom in fact is 5. So, this comes out as equal to 7 by 5. So, with these 2 informations, that U is 5 RT by 2 and the value of gamma is 7 by 5, clearly the 4th option is the correct option. Let us now go to the next question. Question 11 says, a point-like object is placed at a distance of 1 meter in front of a convex lens of focal length 0.5 meter. A plane mirror is placed at a distance of 2 meter behind the lens. The position and nature of the final image formed by the system is, and the 4 options are given. Let us depict the situation with the help of a diagram. We have a convex lens whose focal length is given as 0.5 meter. The object is placed at a distance of 1 meter from the lens. So, let us say here is the object and here is the lens, and the mirror is placed at a distance of 2 meter from the lens. So, where will the lens form the image when the refraction is happening for the first time? Because the distance is given as 1 meter, the focal length is 0.5 meter, we know that the image will be forming at 1 meter behind the lens. It is a real image, it is inverted image, and the distance will be 1 meter from the lens. So, that means the first image formed by the lens is coming somewhere here, in fact midway between the lens and the mirror, because this distance is given as 2 meters, right. So, this is 1 meter, and if we just trace the ray diagram, the rays will go something like this. One ray we have taken like this, and let us say that another ray we take it like this. So, this is the first image, let us call it I1. Now, the mirror will form a virtual image taking this as the object, that means I1 as the object, it will form a virtual image. Okay. The rays will be reflected back by the mirror. Of course, this ray will travel in this way, and we assume that it is again passing through the lens, because if we take. So, what is the position of I2? I2 being the image formed by the mirror, it is here, it is a virtual image, but now these reflected rays, when they pass through the lens, they will form a real image. What is the distance now of the object? So, for the second refraction through the lens, the object distance becomes this distance. Now, since this is 1 meter, this is 1 meter, so this is also 1 meter, and which means for the second refraction through the lens, the object distance can be taken as 2 plus 1 or 3 meter. So, what is the location of the image? Let us apply the lens formula, taking u as minus 3 meter. Well, so the lens formula is 1 by v minus 1 by u is equal to 1 by f. That gives us 1 by v is equal to 1 by f plus 1 by u. The value of f is 0.5 meter. So, 1 by 0.5 becomes 2 and u is minus 3 meter. So, we have 2 minus 1 by 3. And this on solving, gives us 6 minus 1, that means 5 by 3. The value of v itself is coming out as 3 by 5 meter or 0.6 meter. And this is the distance of the final image from the lens. In fact, this is to the left of the lens. Okay? So, final image is the real image at a distance of 0.6 meter from the lens itself. But if you look at the options are given in terms of distance of the image from the mirror. So, if it is 0.6 meter to the left of the lens, the distance of the image from the mirror becomes 2.6 meter. That means among all the options, clearly option 1 is the correct one, matching with our solution that it is 2.6 meter from the mirror and the nature of the image is real. The question is done. Let us now go to the next question. Question 12 says an electron is moving along positive x direction with a velocity of 6 into 10 to the power 6 meter per second. It enters a region of uniform electric field of 300 volt per centimeter pointing along the positive y direction. The magnitude and direction of the magnetic field set up in this region such that the electron keeps moving along the x direction will be. So, the magnetic force has to balance the electric force so that the particle, the electron keeps on moving along the x direction. Now, the topic that is involved here is in fact magnetic force or rather Lorentz force on a moving charged particle. The expression for the Lorentz force is F is equal to, this combines both the electric force and the magnetic force, is Q into V cross B, that is for Q into V cross B is the magnetic force and plus E, which is the electric force. Now, in this particular case, if V cross B is able to cancel or balance E, that is enough. So, that means V cross B must be equal to minus of E vector. Okay? That is a very important point. Irrespective of the value of charge, this condition should be satisfied. Now, if that is so, let us also show the electric field, which is given as 300 volt per centimeter. If we convert this into SI, this becomes 300 into 100, that means 3 into 10 to the power 4 volt per meter, and is directed along the y axis, and the particle is moving along the x direction. So, if we show the situation here, this is how the direction of electric field is given along the y axis. This is the electric field vector, particle is moving along this direction, and as we just discussed, the direction of V cross B should be opposite to the direction of E. So, that means V cross B should be directed along the negative y direction. And if we look at the options in this particular case, only plus or minus z direction has been considered for the magnetic field. Well, that being the case, the direction of field must be in the outward direction, so that V cross B is in the downward direction. So, we have arrived at one conclusion, and that is that the magnetic field, the z component of the magnetic field must be in the positive z direction, not in the negative z direction. What about the magnitude of the magnetic field? Now, since V and B are mutually perpendicular in this particular case, because B we are considering along the positive z direction. So, we have for magnitude V into B is equal to magnitude of E, and that gives us the magnitude of the magnetic field B as E divided by V. Now, the values are given to us. Value of E we just discussed is coming out as 3 into 10 to the power 4 SI units. So, 3 into 10 to the power 4 SI units. The value of V is given as 6 into 10 to the power 6 SI units. So, this is 6 into 10 to the power 6 SI units, and that means that the Z component of the magnetic field should be 5 into 10 to the power minus 3 Tesla. So, if we combine both these results, we find that option 1 is the correct option for this particular question. Let us now go to question number 13.